The voltage is reduced by the main transformer, and this is the electrical symbol for a transformer. Now, this symbol represents a circuit breaker. Circuit breakers have two basic functions. First, they protect loads from potentially damaging conditions by automatically tripping, that is, by interrupting current flow. After the abnormal conditions have been corrected, circuit breakers can be reset to restore a path for current flow to equipment that needs it. Circuit breakers also provide a means of manually isolating loads from their source of power. This helps to protect personnel when maintenance is needed. The electrical diagram for this system also shows the buses that we mentioned earlier, including the 13.2 kV bus, the 2.3 kV bus, and the 480 volt bus. Let's take a closer look at the 2.3 kV bus. This transformer converts the distribution voltage, 13.2 kV, to 2.3 kV. There are circuit breakers on each side of the transformer. The 2.3 kV bus supplies power to 3 different loads. 2 of the loads are motors that are fed directly from the 2.3 kV bus. Each of the motors is protected by a circuit breaker. The other load is a separate bus, in this case a 480 volt bus. A transformer reduces the voltage from the 2.3 kV bus to 480 volts. The transformer also has circuit breakers on each side. 2 motors serve as loads off the 480 volt bus, and each motor is protected by a circuit breaker. Now that we've looked at the 2.3 kV bus, let's do the same for this 480 volt bus. As you can see, a transformer reduces the distribution voltage, 13.2 kV, to 480 volts. The 480 volt bus provides electric power to 2 transformers. One of the transformers reduces the voltage from 480 volts to 240 volts for a lighting circuit, which powers the lights in the area. The other transformer reduces the voltage from 480 volts to 110 volts for a circuit that supplies several 110 volt loads in the area. One load is a motor. The device that protects the motor is a fuse. A fuse works much like a circuit breaker. That is, it interrupts current flow if the current flow exceeds a certain value. But unlike a circuit breaker, a fuse can't be reset. When a fuse operates, it burns open and has to be replaced. Electrical diagrams can be extremely helpful when you're trying to isolate problems with equipment. For example, suppose this 110 volt motor stops working. After ruling out any mechanical or electrical causes at the motor, you can use the diagram to investigate possible causes in the system. Now, there are different ways to troubleshoot a problem. One way is to check the fuses in circuit breakers to see if a fuse blew or if a circuit breaker tripped. The diagram helps the operator determine where the fuses in circuit breakers are for a particular system. By working backwards from the motor, it's possible to figure out where the power is being interrupted. As an operator, you hear a lot of talk about safety, and you're likely to see warning signs around the plant. One thing you should never do is take safety for granted. Many people think that accidents can never happen to them, that safety's for other people. But carelessness and improper shortcuts are 2 big causes of industrial accidents and injuries. Safety is especially important when you're working around electricity. You can't see electricity, but if you don't take precautions, it can be deadly. Your plant probably has rules and guidelines to help people do their jobs safely. Follow these rules to the letter when you work around electrical equipment. A knowledge of basic electrical safety rules, combined with a good understanding of your company's policies, can reduce the hazards related to electrical equipment. Your plant probably uses a series of overhead lines to carry electric power. At some point, you may come across a downed power line. You should always assume that downed power lines are live, and a live line can electrocute you or cause a fire. If you see a downed line, report it immediately. Cables that carry electric power at a plant may be installed in a protective pipe or tubing called conduit, and most cables and wires are insulated. However, cuts or breaks can decrease the effectiveness of the insulation. This could result in a fire, an electrical shock, or arcing. Arcing is the discharge of electricity across a gap in a circuit. Another potential hazard is a leak in a pipe. Leaks in pipes can result in liquid coming into contact with electrical equipment. You can get shocked, for example, if you're trying to identify the source of a leak and you accidentally touch energized equipment. In addition, some liquids can start a fire when they get on energized equipment. Be careful anytime you have to check electrical equipment closely. In some cases, you may smell insulation burning or see arcing, which tells you that current is going where it's not supposed to. If you work around electrical equipment, it's possible you may be faced with emergency situations, such as treating a victim of electrical shock. Your company may have its own specific procedures for emergencies, but here are a few general guidelines to follow if you're trying to help an electrical shock victim and the victim is touching a power source. First, try to cut off the power supply if possible. If you can't do that, try using a non-conducting pole or rope to separate the victim from the electrical source. In some cases, you can even use your belt. But what you should not do is touch the victim with any part of your body. If you touch the victim with any part of your body, you may get an electrical shock too. We've just seen some basic guidelines for dealing with an electrical shock victim. In general, the goal is to isolate the victim from the source of electricity without creating a path for current flow through yourself or others. Learn your company's procedures and follow them to the letter if you're ever faced with this situation. Another hazard that you may have to deal with is an electrical fire. Electrical fires can happen for many reasons, and it may be part of your job to respond to them. Generally, the first thing to do is report the fire. Reporting the fire will set in motion other emergency actions, such as isolating circuits to prevent injury and equipment damage. Then try to cut off power if possible. This takes away the source of ignition. If you're going to put the fire out, be sure to use the right type of fire extinguisher. Fire extinguishers are classified by the type of fire they're designed to extinguish. A Class C fire extinguisher is used for electrical fires. Class C extinguishers often contain carbon dioxide, CO2, which is ideal for electrical fires because CO2 puts out the fire without conducting electricity. You should never use water to put out an electrical fire. Water conducts electricity, and it can cause an explosion or create hazardous paths for current flow. By now, you should be aware of the main concerns related to electrical fires. However, you should still learn the procedures and safety measures that apply to the equipment and hazards in your plant. Our focus in this topic was on power distribution. We looked at the main components in a typical electrical distribution system, and we explored some key safety issues associated with electrical equipment. Take some time now to try a couple of practice questions on this material. Now, this symbol represents a circuit breaker. Circuit breakers have two basic functions. First, they protect loads from potentially damaging conditions by automatically tripping, that is, by interrupting current flow. After the abnormal conditions have been corrected, circuit breakers can be reset to restore a path for current flow to equipment that needs it. Circuit breakers also provide a means of manually isolating loads from their source of power. This helps to protect personnel when maintenance is needed. Another hazard that you may have to deal with is an electrical fire. Electrical fires can happen for many reasons, and it may be part of your job to respond to them. Generally, the first thing to do is report the fire. Reporting the fire will set in motion other emergency actions, such as isolating circuits to prevent injury and equipment damage. Then try to cut off power if possible. This takes away the source of ignition. If you're going to put the fire out, be sure to use the right type of fire extinguisher. Fire extinguishers are classified by the type of fire they're designed to extinguish.